All right, guys, got a special treat for you today. We are going to give you a free, full-length, unedited version of a Schrodinger's Box Quantum Mechanics video. Schrodinger's Box Quantum Mechanics, of course, is my paid channel content where for only $3.49 a month, you get extreme detail training, instructional tutorial videos, a lot different than what you normally see on this channel where, of course, we cover advanced diagnostics, but I assume that you've got the basics and background and things. On Schrodinger's Box Quantum Mechanics, we cover much more instructional detail for computer control systems, performance, emissions, wiring diagrams, electrical, all of that kind of stuff at a much more detailed tutorial instructional level than what you get on the YouTube channel here. So if you really want to learn how to do this stuff, really understand it, be the only guy on your block that knows how to really do diagnostics instead of firing the parts cannon. We have a lot of people who are in automotive tech schools, and they tell me all the time the instruction from the videos they think is often better than their regular curriculum. It's helped many people to graduate from their tech schools and things like that. And also some older mechanics that need to just brush up on new techniques, even if you're doing it as a career. But whatever the case, $3.49 a month, you will notice in this video a much higher level of instructional detail. And if you like what you see, you can watch all the videos you want over on Schrodinger's Box Quantum Mechanics at www.schrodingersboxqm.com. Unlimited video access, $3.49 a month. Also, be aware, just upgrading the server right now again. So we are expanding as the user base has expanded to get more bandwidth, faster video play if many people are watching at once, like when I make a new release. And also, I now have a full-time admin that will be available to answer any issues with billing questions, with any access issues, passwords reset. So they're full-time to respond much faster than trying to get me to do it. So we have all of those upgrades available, still keeping the price the same. Whether or not you subscribe to Schrodinger's Box Quantum Mechanics, I hope you enjoy the video. It's a really good case study. And again, this will be available only for a limited time on YouTube, just to give you a sample of what you're missing over on the other channel. Enjoy. Greetings, quantum mechanics. Well, I believe we have a good one for you today because I am actually not familiar with this system we're going to look at. So the story on this one, real briefly, this is a 1999 Honda Civic that belongs to a kid who works at a Jamba Juice at a mall. And obviously the kid is getting through school and, you know, not a lot of funds right now. So really hoping that this won't be really serious. But he leaves his shift and finds that the car cranks but will not start. So his only choice at that time was to Uber back home. He tells his parents about it, and they start looking around for somebody that can hopefully help. In the interim, he's getting some hate mail from the mall security threatening to tow the car and this and that. So I was contacted to take a look at this ultimately. I did determine that there is no spark, and then also looking at the tachometer, there seemed to be no movement, so of course I'm going in the direction of a possible crankshaft position sensor issue, something like that. While tracing that, I come to find that the system seems a little more complex than I expected. So, unfortunately, with the limited resources that I have available, which was at the time just a voltmeter and a test light, that was pretty much all I had at the time, I was unable to help him as much as I had hoped, but did talk to his parents. We got the car towed over here, and we are going to hopefully fix it. So, like I said, it's got a little bit of a complication, and you'll run into that as we get there. But let's do this. Let's catch you guys up to where I am. Let's reproduce the symptoms as I saw it in the parking lot. Really only a couple things that I could do at that point, and you will be caught up with as much as I know right now. So let's see if we can reproduce the symptom. All right, I am going to remove my microphone here and let you take a listen to the engine as it cranks. Obviously, you guys who have followed me for some time are a little bit clued in here, but I'm not saying nothing. Let's just listen. All right, I am sure you guys will agree with me that this car has a compression problem, but it is not the cause for the no start, for sure. But again, listening to that dip in one of the cylinders, and you can hear that there's not that steady, even beat with the cylinders. One of them sounds different, and that almost certainly is because of compression loss, and it's the starter motor having an easier time going through that cylinder, less resistance, so it changes that sound. That is not the reason this car won't start, though. So we will look at the spark next. That is what I did. Like that, and we'll put a test light up to that. So let me get a test light. All right, using a incandescent test light, not a LED one. Going to an engine ground, I'm just using one of the bolts for the shock here. And I want to first make sure that I've got a ground on my test light. So I'm going to go to battery positive, and we can see the test light does light up there. So I know I've got a good ground. That'll give something for this spark to jump to. All right, going to crank it again. We should easily see that spark. And again, if you didn't follow it before, while I'm cranking, as you see, there will be no spark. Do listen to that sound. That is very important if you're going to do diagnostics in the field. That sound alone, if you're with somebody that's buying a used car or something, you tell them to run. All right, you can see there's no spark there. Hopefully also that compression issue is more apparent. Again, not the cause of the no start, because we would still hear the engine trying to start from the other cylinders, and it would just have a miss in it. That is no spark. And then, of course, what I did was went over to the distributor. And actually, I lied. I didn't, of course, immediately go to the distributor. There would be no reason to do that. What I did was, once I determined there was no spark, I went and looked at the tachometer on the dashboard while cranking and found that the tachometer on the dashboard didn't so much as budge. Might as well go ahead and show you that. You can see the tach doesn't even quiver or anything there. Now again, that is not a definitive test. There are plenty of cars where you do not see the tachometer move with cranking like that. So not 100%, but it was enough direction for me that I'm wondering if there's an issue with the cam, the crank sensor, one or both. And the first thing that I came across was a distributor. It did occur to me one possibility. Maybe there is some issue where we don't have rotation with the distributor. So, of course, I took off the distributor cap. I can see the rotor is right here. And it was handy having the kid around. As he was cranking, I would have him crank. I could see the rotor was certainly turning. And the other thing as well was that this is the main spark output. Usually you're used to there being a wire that comes out of here and going to the distributor cap. So you'll have 9 wires on a V8 or 5 wires on a 4-cylinder, that kind of thing. This cap only has 4 wires because the main output is internal in the cap. So I tested for spark the same way you just saw at this single coil output, and there was no spark there at all. So, of course, determining that most likely this is going to be some kind of crank or camshaft position sensor error, I went and looked at my connector here at the distributor, and that's pretty much where the diagnosis ended for that night. So much to my surprise, for what I thought was going to be a very simple system, there are 8 wires to this distributor here. And of course, I don't know what they are anyway, but that usually is not a problem because, of course, I'm going to determine, well, you know, there's going to be maybe a Hall effect crank sensor. And oh, by the way, If you are not familiar with cam and crank sensors, you may want to stop here and review that video training on cam and crank sensors so you got good, basic, strong foundation of cam and crank sensors, because that's the direction we're going to go into this vehicle here. But really, seriously, if you want to learn this stuff, you've got to have that repetition. I would hope that you're at the point after watching that video that you would know the direction that I'm going to go before I go there. But I can understand if you're just watching for entertainment or just, you know, for a refresher or whatever. But the point is that I'm expecting there to be maybe a Hall effect, maybe an inductive. I'm not sure. I would tell from the wiring. But I don't see why there would be 8 wires leading into this distributor. My guess, of course, you've got a single coil in there, like with any distributor model. So you're going to have a coil signal input, you're going to have a reference, you're going to have a ground. There's 3 wires. You would have up to 3 on your crank sensor. That's 6. I don't know where the other 2 could possibly come from. So the only thing that I could do was, at least I do know there's going to be at least one 12-volt input into this. If for nothing else for the coil, there has to be. So I disconnected the distributor and I grabbed my test light, which of course is already at ground. And I asked the kid to turn the car to on, but not start it. And I know from our basic ignition training videos and whatnot, there has to be a 12-volt reference somewhere on here. So I went hunting and pecking for it, and I still don't remember which one it was. Thought it was one of these, yeah, one of these corner ones right there. Found one 12-volt input, so that was at least some good news there. That tells me right there this isn't likely to be a fuse issue or anything like that. I'm testing the fuse right there. So at that point, just to confirm, and again, I don't know the design of this, I'm just going on guesses right now, but just to confirm that I do believe we've got a crank sensor issue, or more likely, because this is a distributor engine, it would have a cam sensor internal in the distributor. Distributor is driven by camshaft, so obviously your cam sensor very often in the distributor. What I wanted to do was confirm my suspicions here by seeing, was there any fuel injector signal? So the way that I did that would be different than what we're going to do now. Got our fuel injectors right up here. I can actually touch them. So I just held my finger on a fuel injector while he cranked it, and I could not feel any pulsing in the fuel injector. So we got no fuel, at least I think. You know, it's a little hard to tell by that way. We'll do something more definitive. But I believe we have no fuel. I believe we have no spark. Obviously going in the direction of crank or cam sensor issue. I was not able to locate a crankshaft position sensor on the engine. Typically that's going to be near the crankshaft pulley or also somewhere near the transmission using the drive plate as the reluctor wheel. I was not able to find anything on the engine, so I'm assuming most likely internal with the distributor. There was not much that I could do at that point. Of course, tried banging on it a little bit, hoping to get it to work. Sometimes with a bad sensor, you can tap it with a screwdriver or something. Had no luck with that, and I told the kid, well, this is as far as I can go, but I believe that's where our issue is. So that's where we are now. One thing I do want to do is a couple things. First of all, I have my scan tool here. So I am thinking we can just hook up the scan tool, and I will bet you there is going to be a cam or a crankshaft position sensor error code. The other thing that I could do is I just want to, just for my own confirmation, really definitively confirm that we have no signal to the fuel injectors. And there is an easy way that I can do that just looking at the wiring. All right, we've got all 4 fuel injectors in view here. And there is something that I can observe very easily here. And that is that each fuel injector, of course, has just 2 wires. It's going to have a power input and then a ground. And that ground, almost guaranteed, because I've never seen to the contrary, that ground is going to be PCM controlled. So the way this works is you've got constant power to the injector. And then when it's time for that injector to fire, the PCM closes the ground, which of course completes the circuit, opens the injector, and then it opens the ground, of course, turning that injector off. And it uses the cam and crankshaft position sensors to know which cylinders to do that for at what exact time. Looking close at the wire, I can see we have a yellow with a black stripe wire here, a yellow with a black stripe wire here, a yellow with a black stripe wire here, and a yellow with a black stripe wire here. So what this is telling me is that on this design, we have a constant power feed that splits in 4 places, 4 branches to each injector. And then we have a different colored wire as the second wire. This one looks like red something. This one looks orange to me. This one's blue. And this one's a solid yellow. And what that's telling me is I know where the grounds are because the wires that are the same color, that is going to be a constant power feed. The different colored wires on each injector are going to be the ground, respectively going to PCM terminals. Now, maybe I'm wrong about that. I've never seen a fuel injector that was power side controlled. Even so, if that's the case, it would be the other way around. The yellow with black would be a constant ground on all injectors, and there would be different power feeds turned on each time at each injector. I doubt that's the way it works. I think it is the first method, but either way, I can easily test this with my test light and confirm if there's signal or not. And that's without even looking at a wiring diagram or anything. It is one of those 2 possibilities. The different colored wires are either individual grounds or individual powers. They're almost guaranteed individual grounds, and I can test whether those turn on and off. All I'm going to do is take a back probe and feed it into one of the different colored wires. And in one step, I'm going to be able to tell that I am correct, that this is going to be a ground side switch system. So let's see, did I leave the key on? It looks like I did, good. So with the ignition on the ground side, you can see there's power. The only way I could have power on the ground side is if that ground side switch is open. Think of our basic electrical series, right? So if that ground side were to close, the light would turn off. Now, it's also possible, of course, that we are on the power side of the injector, and each wire that's a different color is the power. So how do I know the difference? Well, it's very easy. I'm going to just unplug the injector. If I am on a power, that light will stay lit. If I am on the ground, we now lose that power connection through the injector, and the light will go out. And you see the light goes out. So there is no question about it. This is a ground side switch system. We'll probably go ahead and review that really quickly on the dry erase board, but just that simple test is telling me there is no question I am on the ground side of a ground side switch system. If I'm on a ground side switch system, when I'm cranking, that ground should open and close, open and close, open and close. Every time that injector needs to fire, that ground should close and the light will go out every time that injector needs to fire. So let's see if that happens. That was really unexpected, actually, to be honest with you, because I didn't feel the injector pulsing when I had the kid cranking it, but of course you've got a lot of vibration and things going, and it's also not nearly as rapid and pulsing like a hummingbird's pulse rate would be when the engine's running. So I missed that. This is something that I could have done in the field, but you know what? It doesn't really change anything except for now, you know, I just don't understand this system more is what it is, because I don't have spark, but we do seem to have fuel. So it could be a bad coil, could still be a crank sensor. Again, no RPM indicated that, but that is not definitive. Well, you guys are as caught up as I am now, but I was not expecting that. But we do have control to the injectors, so that is a clue. So my problem is this. My problem is that it would normally be very easy for me to determine if we just have a bad coil here, but with 8 wires, I really don't have a way of knowing. What I want to do, obviously, is I want to test this coil by putting an input signal to this coil, but there are too many wires here to figure out this system, so there really is no way around it. I need to get a wire diagram. The other thing is, again, I am not familiar with this. It still could be whatever the sensor is in here, a camshaft position sensor. This car still may have a crankshaft position sensor responsible for this, but at least if I could get the coil to spark myself, we could rule that out and we know which direction to go. But I can't, this is going to need a wiring diagram because I have no idea why there would be 8 wires here. I honestly can't even fathom that. So why don't we do this? Let's go to the dry erase board. Let's cover the strategy that I used for this fuel injector here. And then I'll go do some research and pull a wiring diagram and we'll go over it and we'll figure this system out. All right, so I just want to review with you guys because I want all of you guys watching to be able to do what I just did, and that is walk up to a system, take one look at it, and already have an idea based on the basic electrical training that you have, understanding these systems from the previous videos. Without even looking at a wire diagram, without looking at a manual, we know that is the design of this system. There is no question about it. I'm not even going to look it up in a wiring diagram for real. There is no need to, because we not only know this is the only way it can be, but we proved it too. And we also showed it's working. So you're going to have a power come in. It'll be fused and it branches off. So every wire is the same color for the power to each injector. And then each injector has a second wire off of it that's a different color. Each different color is the control wire, and it's ground side controlled. So each one is going to go, maybe this will be 1, 2, 3, and 4. Each has its own transistor, sometimes called a driver, and the PCM will know from various inputs, typically camshaft position sensor, crankshaft position sensor, one or both. And the PCM will know which one of these to close to ground and then when to open it again. How did I know for sure that the colored wires are the ground? Well, let's just take a look at one wire here. So again, we've got constant power coming in. So we've got power coming in there. Now, I don't know that 100% for sure at the time. What I did was I back probed here at the ground. Back probed at the ground, and of course I've got my test light here, my test light bulb, and my test light bulb was on. Now, of course, that's because we've got the power coming through here. Remember the basic electrical training videos. The power is coming through here. It's going through the coil in the injector and then to the ground, but this is open here. So remember, filling the hose analogy from our basic electrical, we're filling the hose with our electrons. They've got nowhere to go. Anywhere I measure, even here on the coil, here, anywhere I measure along this system is going to measure battery voltage, anywhere that I measure. The only way that changes is when this connection to ground is made. Once it goes to ground, anywhere I measure on the positive side, that light's going to light. But after the load, that light will not light because we're going to have full voltage drop across that load. Remember our training. Now, I, of course, did this a different way, and that is, again, let's go back here. This is open right here. So anywhere we measure, we filled this hose, we've got 12 volts anywhere that we measure along this line, even on the ground. But what did I do? I disconnected from the injector. Well, look what happens. When I disconnect from the injector, we've got our power here, but then there's no connection of that power through the coil in the injector over to this wire that I'm back probed on. So I'm back probed on this wire. Now that we're disconnected, that power ends here. So when I disconnect that connector, the light goes out. connect it back up again, now our power goes through the injector, but it still ends here, but it's still present here, so my light lights. And that's how I was able to know that I was on a ground. Again, if you're still not following that, review that basic electrical series and it'll make sense. But I'm able to do that right in the field. I can take one look at that wiring and I go, oh, I know how I'm going to test that. When we first connected up, when the power was just on, but I wasn't cranking, well, of course, we have the test light lighting, like I said earlier. But then while cranking, this ground is being turned on and off, on and off. When the ground is being turned on and the ground is connected, we lose our voltage on the ground side. Remember our voltage drop lessons, so that light goes out. Half a second later, the PCM is commanding this to be open. Now it's open. We've got our power filling the hose. It's stuck here. Light goes on. PCM says, okay, let's complete the ground. It completes the ground again. We lose our power on this line through voltage drop. I'm tapped into where there's voltage drop, the light goes out. So hopefully that makes sense to you and you are comfortable being able to test a system like that and identify whether it's ground side or positive side controlled just by looking at it sometimes. All right, but while I am able to create my own wire diagram for that system, I honestly, for the life of me, cannot figure out why there's 8 wires going to a distributor that just is going to have a camshaft position sensor and a coil. I don't understand that. So there's got to be more to it, and I cannot guess on it because at this point, your average 98%er is going to be putting a distributor in this vehicle, most likely, not even messing with it. Well, actually, strike that. What they would have done is put plugs and wires in the vehicle. But as we can see, there is absolutely no benefit to doing that. And again, what are they going to say? When they put the plugs and wires and the vehicle still doesn't start, what is the mantra that they're going to use? That's all right. Needed them anyway. Right. Yeah. Why are they not replacing the drive plate on this vehicle? Doesn't it need it anyway? I don't see them replacing shocks on the vehicle. Doesn't it need it anyway? So, yeah, we don't do stupid excuses like that. We are going to know for sure what is wrong with this vehicle. So let me do some research. All right, we have our wiring diagram, and now I can easily see why there are so many wires to this distributor. It's because there are a lot more components than I had expected, actually 2 more than I had expected at least, and I am not even sure what they are, so I'm going to have to do more research. But again, with the wire diagram, always starting with the thing you're working on. It's a lot easier than looking at 6 million wires here. We're going to start right here. This is the distributor assembly right here, and we can see that it is made of a lot of stuff in here. So the first thing is the CKP. That, to me, is a crankshaft position sensor. You know, I don't know why it's crankshaft position sensor. I believe it should be camshaft position sensor because the distributor is run off the cam. But anyway, I guess they call it a crankshaft position sensor because if the cam and crank are in time, I guess indirectly it is a crank sensor. But whatever the case, we've got a white wire that is coming in from the computer. Actually, strike that. Technically, it would be a white wire going to the computer, to be really technical about it, because this is going to be signal out. So let's follow that. I'm going to use this kind of really bad marker here. And that goes to CKPM. And I am not sure what the M means. This is obviously going to be an inductive sensor. We know that from our training videos on cam and crank sensors, so I'm guessing maybe that's whatever the M is, it's either positive or negative. Maybe the other wire will be a clue. The other wire is blue, and you can see that they change colors after the connector. This is really common that you see that they change colors after the connector. but I'm just interested in this side. And actually, I'm probably going to draw this over again on my dry erase board anyway. I often do that on these more complicated systems because that way I can draw just the system I am interested in. Anyway, that comes across here and it goes to CKPP. I'm assuming CKPP is crankshaft position sensor positive, and maybe that's negative. I don't know, but whatever the case is, I know how it's going to work. I just don't understand the labeling there. The TDC is our next one here, and we've got red and green wires. I don't have a red marker, I don't believe. I'm going to trace that up in pink, and that goes to a TDCM. All right, well then I'm going to guess that the green wire then will go to a TDCP, whatever that is. I honestly don't know. TDCP is the green wire there. And TDC, of course, to me means top dead center, so I'm guessing it's some kind of maybe top dead center, cylinder number 1 position, something. I honestly don't know. I've never heard of that in my life before. But again, we can see this is definitely going to be a similar design as our CKP here. It's going to be an inductive 2-wire sensor. It's going to generate voltage that we will be able to pick up if we need to test that. And then this third one, I really have no idea because I can guess what CKP and TDC are. CYP, I honestly can't even fathom a guess. Camshaft, yaw position, hell, I have no idea what that is. We've got a black wire, and that goes, I'm going to just take a guess, CYPM probably. My black marker is dead. Let's do, and actually we'll do that in a thicker black so it differentiates from the other one. And then we've got a yellow. Do I have yellow? I don't have a yellow marker. I am just going to leave him alone, I guess. And the yellow is going to go up to a CYPP, and it does, CYPP. So I will have to research what those sensors are. I am not quite sure, but there are some other things that I do know. One of them is going to be this yellow and green wire. I really like my yellow and green wire. That is important because that is our ignition input signal. So I definitely want to trace him. He should go to the PCM somewhere. So he goes up here, and he does go to the PCM where it says ICM. All right? And that is in the ICM. We see we have the ICM here, the ignition control module. That is part of this assembly. We also have a blue wire coming out, and that is RPM output. And now I'm wondering, bad ICM, not seeing the RPM, if that could be a factor there. I don't know. What else do we have coming out? We got to have our power. We have not had a power come in yet. And that I know is that black and yellow wire, right? That's the very first thing we did. There he is right there. Black and yellow wire. And that goes right to powering the ignition coil, which is also in this assembly. That is going to go right up to a fused power that is going to be on with key on. All right. It says on or start up at the top. What else do we have here? There's also a black and yellow wire here that also goes to the ICM that forks off of that power wire. So that is possibly some power for the ICM. Maybe, not quite sure what the deal is with that. I will try to look up more about this ICM. It looks like the ICM ground side controls this coil because here's primary output control, but it's on the ground side of the primary winding. So that must be how that works. That's a blue wire there. That is going to be internal, I believe, in that distributor. Those wires are not out here on the connector. And so, based on this, yeah, quite honestly, I have some more research to do because I need to really understand what the TDC and the CYP are and what their roles are in producing that output, that ignition in signal. I need to know how those factor in. But now that we've got all this complication going here, I would like to get that scan tool on there and pull some codes, and maybe it won't be a crankshaft position sensor code after all. All right, let's see what we get for some codes here. And this is a little disturbing. Why will this not connect? Should be on a Pro line, it is. All right. So sometimes on some cars you have to have them actually running in order for them to read with the scan tool. Right now I can just do ignition on. So let's try reconnecting again, but this will suck. Yeah, this is not going to be able to connect. All right, well, let's try one more thing. Let me get a basic code reader and just see if we can read the codes with a code reader. All right, a little secret here. So you remember my guys from launch with the CRP Touch Pro that I really loved, absolutely loved that. Well, initially they had sent me this to review, which is just pretty much basic code reader. To be honest with you, I told them I wasn't going to review it. I really didn't like it. They sent me this anyway. And I was like, I don't know why you would do that. I am not reviewing this because I really, it's just a code reader. Yeah, they just gave me this thing. We have no fault codes. Wow. Well, that complicates matters a lot. All right, well, what do you do in this situation now where you don't have a direction, you can't really get one very easily, and you don't understand the system so well? Well, you have to make your own direction in this case because we don't have help from the scan tool, and we didn't get a lot of help from the wire diagram because we've got some components that I don't know what they control. What I do know is we have no spark and we have fuel. I am kind of leaning still in the direction of the crankshaft sensor just because of the RPM thing. That's, again, just a guess. And it's okay. I'm not guessing at replacing a distributor or something like that. I'm just guessing at what could explain the symptoms that I see. And then we will eliminate or validate that guess. Another very good possibility could be there is just a bad ignition coil on this system. That is entirely possible. I just I'm a little bothered by the tachometer not moving, but maybe that doesn't have anything to do with it, and the tach only works when the car's running. I don't know. What I think the best way to get a direction would be to understand what those, what were they, CKP and CYP components are, because that would help to give us direction because we would understand what controls the spark in this system, and then we have some way to go. Doesn't that make sense? So I am going to hit the books, and as usual, I spend far more time doing research like this than I do actually fixing the vehicle. So I will spare you those details, but I will come back after I learn something. So we will continue this. Okay, so I did do a little bit of research on Google and stuff online, and I honestly did not find much, but I did find enough that I think we can move forward on this. So let me do this. Let's redraw our diagram in a little more simple fashion on the dry erase board because I can just copy that right off of this confusing wire diagram and focus just on what we need. So let me do that. All right, so let's start here. We've got our PCM with our inputs and, well, maybe some outputs too. Like, for example, the ignition signal would definitely be an output because this is ignition in over here on this ICM, this ignition control module, which is all in the distributor and coil assembly. So we got our PCM here. This big black box represents our distributor and coil assembly, also ICM assembly. Everything's all in the distributor. Little worrisome. I'm wondering if we just have something with whatever this CYP sensor is. Can you just replace that, or do you have to replace the whole distributor? So I'm not totally sure on that. That would seem wasteful, but that may be possible that it's not serviceable. Let's start off here with our distributor, coil, and ICM unit like that. we know that it is indeed a crankshaft position sensor. CKP turns out to be crankshaft position sensor. I'm going to claim that it is technically more of a camshaft position sensor, but if the cam and crank are in time, I suppose it is a crankshaft position sensor. We've got a white wire and a blue wire, 2-wire system for this sensor going into the PCM. And what does it control? Crankshaft position sensor controls fuel injection. So the fact the fuel injectors work, there goes my crankshaft position sensor theory, right? Just on that alone. Oh, well, no, that's not true because there is a little more to it. There is a little more to it. It also controls the ignition timing, but while the car is running. Okay, so not during cranking, at least as far as I understand. And it also detects the RPM as well. Now, we didn't see RPM, but I believe there is a good chance, actually a really good one, that it may be this crankshaft position sensor is not used during cranking. So that is because these other sensors here, if we list what they do, so the top dead center, and it is indeed, like I said, top dead center position sensor, and I'm assuming it's top dead center on number 1, but that will actually get a little complicated when we talk about the CYP. Whatever the top dead center sensor is, and you know what, now that I think about it, it's probably a top dead center sensor based on the camshaft position or crankshaft position for each cylinder, now that I think about it. Whatever the case is, the top dead center position center determines the ignition timing while cranking the engine. It also has a secondary feature, and it's to also determine if there is some issue with signal from the crankshaft position sensor. So my guess is while the crankshaft position sensor is going to be outputting a signal, it is actually the top dead center sensor during cranking where the spark timing is determined. And that gets us to our CYP, and what that is it is a cylinder number 1 position sensor, cylinder position sensor for number 1. And this, it wasn't very clear on, but what it does do is it detects for the fuel injection, and I believe that's during cranking. So during cranking, your TDC and CYP, at least as far as I understand, during cranking, those come into play for your ignition and your fuel. And the CKP, the crankshaft position sensor, is really used once the engine gets started and it's running. That's at least my understanding of it. Now, obviously, I'm a little wavery on that because I couldn't really find complete information on these sensors and when they are used, but I just know the CYP controls fuel injection. My guess, CYP is working. We have fuel injector control, we know that. I'm now kind of aiming towards this top dead center control because we certainly don't seem to have the ignition timing worked out. So we'll need to see if we can find a way of testing this, and we've got our wire colors of red and green on that one at the connector, so we could do that. Because CYP seems to be working, we have a positive control. So if we can detect signal off the CYP, we can do the same method and see if we have it on the red and green wires for the top dead center control, and of course for the CKP. I do believe the CKP, the crankshaft position sensor, really isn't the issue as I originally thought because we've got these additional controls. Why we have a CYP sensor and a TDC sensor, why those can't just be one thing, and why everything can't be done off the CKP, I don't know. I have no idea why this system is like this. All right, so those are our sensors. So I'm not sure if that's replaceable or not, if we find an issue with any of these, or if you have to do the whole distributor, but I have a direction now. I know where I'm going to go with the testing. We then get to our ICM, which is also internal in this distributor. That is your ignition control module. And you can see that we've got an RPM output. So for the tachometer, that'll eventually go to the tach off this blue wire. We have a green and yellow. I forgot to write that. This is going to be very important. green and yellow. That is our ignition input. So when a signal is sent from the engine computer, obviously based on input from these sensors, it will put an ignition signal output that will ultimately fire the ignition coil as commanded by the ICM. So what I'd like to do is do a test on this wire. First of all, see if there is any ignition input. If there is an ignition input on this green and yellow wire, well, I am going to say that all of this works, and we have a coil problem. The other thing with the coil, of course, we've got a positive input to the coil, and it looks like we've got a primary coil control in the ICM, and that is going to be, where's my wiring diagram? Where's my primary? That's a blue wire. So I did label that blue. And then obviously once that primary coil is charged, and then once you release that ground, we're going to cause a collapse of the magnetic field to the secondary, and that of course is going to go directly to the coil wire, right to that coil output on the distributor itself. So we have a couple of ways that we can test this coil and see if the coil works. So we've got all kinds of things we can do now. It's funny, now we have the exact opposite problem as before. Earlier, we really didn't have a direction to go on. Now I'm thinking, do I just want to go ahead and try to fire this coil on my own and rule out if the coil's the problem and it's more a control thing? Or do we want to test our controls and rule out any of those failing to send signal to the coil? I think the best way to do this, I am pretty convinced from the little bit that I understand on this, I am pretty convinced that if we have signal on this ignition input, if there is signal on that green and yellow wire into the ICM, all of this can be ruled out. I believe you're going to need these working in order to produce that signal. So I think we're going to start there. So one of the things, I'm getting a little sick of cranking the engine and sitting in the car. I just noticed the fuse box right here. So I may just go ahead and make a remote starter out of the fuse a relay real quick. Oh, check it out right here. There's a fuel injection fuse right there, 15 amp. And I can just see, if this was on the YouTube channel, all the armchair experts, well, you're an idiot, you didn't check the fuse. I would have checked the fuse first. I always check the fuse first. It's just so funny because you guys saw the very first thing I did was check the fuse, because we have power at the connector right there, which only can be possible with the fuse there. And it's just so funny to see that. I'm not even going to check that fuse because I know there's power to it. It's ridiculous. It's like having a lamp on in your living room. Well, check the circuit breakers. The lamp is on. Oh, for God's sake. All right, so I've got some wire here. And what I'm going to do is put this wire to a ground here. Make sure that's on there really good. And I'm going to make sort of a spark plug in a way. So I'm going to run this along and then have this gap right to the coil output. Yeah, like that. So if I do produce a spark, I should be able to see it jump to the wire, and it'll just go to a chassis ground there on the shock tower. And first thing I want to do, I want to make sure that I got a ground there, because remember, I'm going to be right here, and I don't want any chance that that spark jumps to me if I don't have a good ground. So I'm going to put my test light onto battery positive. And with my test light on battery positive, if the test light finds a ground, I know that it should light. So it should light there, and it does. So I know I've got a good ground wire there, and that means that the spark should have no problem jumping to it. Let's see here. Oh, what was I doing here? Oh, yeah. There is no starter relay at this location, so I think I'm going to try to do some tests without having to start the car at this time, because it's a little problematic doing that with the camera and all that. So I am going to look at my wiring diagram, and I'm going to look for that input signal, that ignition input. And I'm pretty sure that was yellow and green. and I can see it on my wiring diagram. I can also see it on my dry erase board a lot clearer than I can here. And let's just see here. Yep, yellow and green. So there is definitely a yellow and green wire right there. Let me get a back probe. It is yellow and green. And if I put low amperage to that, I could just use my test light. Should be able to create an ignition signal and create a spark. So the first thing I need to do is make sure the ignition is on. All right, we'll adjust my spark gap so you can see that, and we'll see if a spark jumps to there. And what I want to do is get my test light to battery positive. And I just verified we've got ground there. So I want to put a little signal in here, just low voltage, and wow, nothing happens. So again, there may be other factors with this where I can't do this. On a typical non-distributor ignition, this would cause that spark to jump. So either the coil is bad or there is more complication to this system. I guess it's possible that grounding it on this design, maybe the PCM grounds it. I highly doubt that. I may just go ahead and try that, but I'm going to move my test light over to the battery negative, so now I could ground that signal out. And yeah, I'm not sure whether that's just a coil issue, which is our problem on this car, or more likely there are just complications with this where I can't do that as simple as I can on more modern vehicles and just generate that spark through a input. So now what do I want to do? So one thing I could do is try to go directly to the coil. So one of the problems, though, is that the coil is ground side controlled through a blue wire, but that unfortunately appears to be internal to the distributor. So I would have to take this apart in order to do that. And that is okay, but I want to just rule out some easier things first. So what I wanted to do was just go right to a confirmation on this coil, jump a spark from the coil's good. Unfortunately, it doesn't look like I'm going to have that much simplicity with that. So what I have to do now is either take this apart, or I could easily rule out everything else except the coil. That would be an easier way of doing it. All right, well, it is a little complicating now that my ignition input test there did not produce a spark from the coil, and that means there's a few more variables here, unfortunately, and not the least of which is some of them that maybe that test is invalid because there's a little more complication. But it seems pretty obvious to me. You've got your inputs here with the CKP, TDC, and CYP that ultimately will have the PCM output an ignition signal that will spark the coil. I put in my own ignition signal and did not spark the coil. So our variables are, we may have a problem with the coil. The coil itself could be bad. We could have a problem with coil ground because that was not tested. We also could have a variable where there is more necessary in this system than just this ignition input, but I don't think so. It does look, well, you know, the ignition output to the coil looks like there may be some control from the ICM, and the ICM may be using some different inputs, not shown on here. But yeah, you know, honestly, I've actually, on any other car, if I test the ground and I put a signal into that coil, and there's also 12 volts to that coil, which I know there's 12 volts to the coil. That was the very first test we did. If I put that signal in with my test light like that and that coil doesn't fire, I'm done. That coil's bad. So if this was on like a coil on plug on a more modern car or something, but again, we did not test that the ground works on this. So we do have a variable with that. Could also be a bad coil. Again, removing the distributor would be necessary to examine that. There is another possibility that I think I could do. Again, we tried to put my own ignition signal into the coil, but I am also convinced that these sensors ultimately produce that ignition output from the PCM. I think I can test all of these at once if I can crank the engine and verify there is a signal on this green-yellow wire. Now that's a little bit more challenging done than said, and that is because usually this is really low amperage here, so it's not like I can just back probe this and put my test light there and see it flash like with the injector signal, the fuel injector signal. These generally don't work like that where there's not that much amperage in doing this. So what I may be able to do, though, is use a LED test light because that requires far less amperage. But you're not going to be able to just use a regular test light for this. So really, again, the best way to test that would be with a scope. If I put a scope on there and I see a square wave, that I'm done. That's going to rule out all of my sensors here, and I'm going to say we've got a problem with the coil or some coil ground issue, and that would eliminate all my other variables. So I think that might be a good way of going. I do also, just to understand the system better though, I do want to look at these outputs and verify, because again, I'm expecting these are going to be inductive sensors, and we should see that kind of oscillating wave if we looked on a scope. And we may do that just for educational purposes, just so I can validate my understanding of the system seems accurate. But right now, let's just go ahead and verify if we can get signal at this green and yellow ignition input, which would tell me that, if nothing else, the CKP and TDC must be working. I'm already positive the CYP is working because we saw fuel injection signal. So let's try that. All right, I'm going to keep my little sparky guy there just so that if I do produce spark, since I'm going to be working around this area, it's less likely to jump to me. We've still got our test light onto the battery negative, so let's touch it to the battery here and make sure. And yeah, you can see just on the corner of the screen, the light lights up. So again, what I'm not going to be able to do is just put that test light into there and expect it to light as I crank the engine. That's not going to happen because there won't be enough amperage to light that light. But what there will be is with a LED light. So what I'm going to do is get this LED test light. I'm going to put this on to battery negative. And this should flash. So you can see right there, we do actually have voltage on there right now. That would not have been enough to light up my incandescent light. You need 250 milliamps to light that light up. We only need, I think, it's something like 20 or maybe 50, but I think it's more like 20 to light this guy up. So what we're going to do is crank the engine, look to see if that flashes. And this may actually rotate rather rapidly with the one output here. So this could actually flash very fast. So to make it easier, I'm going to turn the lights down. And let's see if that flashes as I crank. If it does, that's going to be pretty clear indication to me that this computer is receiving signals from here, from the CYP, CKP, and TDC sensors, and producing an output. So let's try that. All right, well, it did look to me like that was flashing, albeit fairly rapidly, and it was a little bit hard to confirm 100% that it was really flashing because it didn't seem there was time for the light to go out all the way. But that did seem to be control to me. Again, another reason why a scope would be so helpful. That may have been a little bit inconclusive. A square wave on a scope would be 100% definitive. And I think at this point, that may be where I want to go next. So I think what we're going to do, if I didn't have a scope, I would go on the assumption that we have signal to the coil and the coil is not firing. And this would rule out all of my sensors, my CKP, TDC, CYP is all working to produce that signal, but I need to be 100%. So I am going to hook up the scope, and we're just going to verify that what we saw was legitimate control for that ignition signal. So I've got my lead wire, which will go right to the channel 1 in the picoscope. You got a lot going on here right now. This looks like a mess. What I want to do is get a negative lead, and that's going to go to ground. Hey, I got a nice ground wire right here. As a matter of fact, my spark wire will serve as a ground. And then my positive lead, where is that? My positive lead is going to go right to that ignition signal. And let's see, not sure what time frame we'll want here. We'll just start at a half a second. We don't need a trigger right now. And I don't think we're going to be at a 20 volt scale. Let's just bring that down a bit. We may have to adjust that later. That may be enough that we can see if we have a square wave on this thing. So let's give that a try. Oh yeah, that's a real signal for sure. Let's go ahead and clean that up a little bit. So let's go ahead and stop that. Go back to it. Okay, so we can see that we need to actually increase the voltage scale as well as the time frame, make it a lot faster. Let's do that. We'll just try that without a trigger. I don't think we need to freeze that signal. It should just be an on-off square wave. It would help if I run it. So we got to go up here to this top corner and run it to go live. That's a square wave. Yep, that is definitely a square wave. So, boy, you see how handy having the scope is when you've got things that are just a little difficult to interpret. So that tells us that we do have a ignition input signal going in there, and this coil is still not firing. So what does that tell us about our sensors, the CKP, CYP, and TDC? Those must be working. You know, while we've got this scope hooked up, let's just test one of those, because we know that that is not going to be expected to be a square wave signal. So let's do this. All right, what I want to do is I just want to show you, if you did not have a scope, well, you would probably have to use your standard digital volt ohm meter like this. And we would put it to a 20 volt scale. We would put one end of it over to a ground, and we can still use our little spark wire ground there. The other end would go to your sensor. This one's from the picoscope. I know it looks like a mess here. And what we would do, oh wow, you can see that we do already have 12 volts there already by default with the engine on. And what we're going to see is, based on that output, you might expect that you're going to see 6 volts because you're going to have an average of the on-off. But remember, look at our duty cycle. Let's go back here. And, oh crap, it looks like I left this running, so I think I ran it off. But if you remember our square waves, I'll put it up in the corner here for you, but if you remember our square waves had a much, much longer on time than off time. So that's going to skew that average. So out of that 12 volt on-off signal, well, you've got more time on than off. So this is going to be more like an 8 volt signal that we would see on the multimeter. The only problem is that you don't have any way of telling that that's an average from a square wave. You're just going to see 8 volts, and you don't know if you've got a low voltage problem or something, or if you're just looking at the average from a square wave. So again, the reason why a scope is so helpful, let's go ahead and bring that voltmeter over. All right, we're going to do the same exact test as we did with the scope, but this time trying to measure it with the DVOM. And we did. We get about 8 or 9. So again, you can see, is that your indication that you've got a perfectly valid square wave? Or is that indicating that we have some kind of a voltage problem? You don't know unless you've got the scope. All right, so now what we're going to do is we're going to do the same thing, but we're going to do it on one of these sensors. And I know that these sensors are going to work. We've got crankshaft position sensor. So that, if we look on our wiring diagram, we've got our 2-wire sensor. So we are not expecting this to be a Hall effect sensor where we would see a square wave. We are expecting this is going to be more of a sine wave type signal. It's going to produce an AC voltage. And we, again, can do the same thing. We can test that with the voltmeter, but it won't be very conclusive. On the scope, we're going to see that we've got the pattern that we want. We've got a white coming in that then transitions to a light blue and yellow. And then we've got a blue that comes in that transitions to a light blue. Okay, so looking at this connector here, we have our crankshaft position sensor. We've got on the one side of the connector where it comes in from the PCM, we are going to have a white wire coming in that then changes to light blue with yellow towards the distributor on this side of the connector, and there is not a light blue and yellow. There is definitely not a light blue and yellow on here. Wow. Okay, so this wiring diagram has a mistake in it, I believe. We have a white wire coming in that transitions to white, blue, and yellow. So let's look for the white wire coming in. There's a white wire coming in right there, and that lines up with this wire that is solid white. And that is not what this says. There is a solid white on this side of the connector for the CYP, and that would cross with a black coming in. So let's see, where's a black wire coming in? This corner right here is a black coming in, and it's also black coming out. So, damn, this wire diagram has some errors here. In this case, I can tell you that the wires coming in definitely look consistent with the connector. It's the wires on the other side of the connector that are not consistent, and I wonder if that could be from a distributor replacement at some point previously. So I'm going to go based on the wires coming in. We would be more interested in this TDC position sensor because that is more relevant to the ignition with cranking. We know that's going to work because there's an ignition signal, but it just makes a more relevant test for this example. So let's see, if we look at the TDC, we have a white with a blue stripe and an orange with a blue stripe. There's a white with a blue stripe right here. Just to be sure, because again, we're not 100%. The white with the blue would be opposite of a red coming in, and it is. There's a red coming in right there, transitions to white and blue, so this wire matches up with our diagram. Going to probe him. And then the other one on the TDC is going to be a green wire coming in that transitions to orange and blue. Where is a green wire coming in? There's a green wire coming in, second from the right, and there is an orange and blue coming out. That would be him. All right. So now we've got our TDC connector probed. And again, this we are expecting, we know it's going to work, but I am expecting that this is going to give us a kind of sine wave pattern, not a square wave. Let's first, because we already have the DVOM hooked up, let's take our DVOM. I'm going to set it to a 20 volt AC scale. And this is just going to prove our concept that we know our basic electrical and we can anticipate things based on that and verify that they go according to plan. All right, let's see what we get here. All right, well, you see we definitely have some signal there. Now again, is that our sine wave? Is that a good signal? Can we say, yep, we have definite output that we know is good? I don't know. I don't feel comfortable with that, and I never did even before I owned a scope, and this is how I would do it. Kind of feel like I'm guessing a little bit. Sure, indication is pretty strong, and it's better than if we didn't see any signal, if we saw nothing at all on there. Oh yeah, definitely, some issue, for sure. But is that the right signal? Well, let's verify it. So we'll go to our scope here, and we need our positive from the scope. We'll go, and it doesn't matter the polarity here, honestly, but we're going to do the positive for the scope on one of these, and then the negative wire, which was on our spark catch there as a ground, that's going to go on to the sensor ground here. At least I think it's sensor ground, I don't know. Doesn't matter if I mix these up, we're just going to have a sine wave. And let's take a look here. All right, so looking at this, I do believe it's probably making sense, even though it's not exactly like I said earlier. In retrospect, this is a, a top dead center sensor. So it's only going to catch, I believe, on the top dead center positionings, as opposed to, say, a crankshaft position sensor where you would get, I expect, much more of the usual consistent sine wave. But that's definitely a specific signal, so we know that that's working. And of course, we knew it's working anyway. We have an ignition signal. Just to be sure, 100%, I'm sure 100%, but just for demonstration, really, I'm going to go ahead and hook this thing up to the crankshaft position sensor signal. I fully expect we should see a different pattern where it's just nothing but these sine waves. So let's see if we can do that. All right, again, looking at our sheet here, crankshaft position sensor, we know we've got white coming in, yellow with blue coming out, but that was not correct. So I'm going to go to this white coming in, and it's a white coming out, and that's all right. It's not what our diagram says, but our diagram is incorrect on that. I am sure of it. All right, and then the other side of the crankshaft position sensor, we're going to have a blue coming in with light blue coming out. That one I know is accurate. I remember. So there's a light blue coming out. I am satisfied with that being the correct one. Back probe him. We'll get our leads on there for our pico. And let's see what this waveform looks like. Hopefully you know this isn't just showing off the pico scope. This is to validate my understanding of this system, which is going to make me more certain in making my call, because everything is adding up and making sense, except for the thing that isn't functioning. And again, I got to press the start. Got to go up to the corner here and press run. Okay. That's what I expect. Yep, that is what I would expect an inductive crank sensor to look like for sure. So everything absolutely is making sense to me. Hopefully it is to you. So your average hack is long before any of this. They would put a distributor in the vehicle. Most likely they would fix it. Most likely they would, on a guess. But here's the problem with that. The problem with that is that there is one explanation. Let's say that we had done the ignition test with the scope and we saw our square wave. It didn't look anything like that. Remember, it was sort of a very long on-duty cycle like that. What if we did this and we did not see a square wave? If we did not see a square wave, now you can't really be sure that replacing the distributor is going to fix that. Because if we do not see this square wave here, if we just saw a flat line here, what are the explanations for that? Well, one of them would be any sensors here that are responsible for that square wave production are failed, and of course replacing the distributor would ultimately fix those. Or we could have it where the signals are functioning and they're reaching the PCM, but the PCM is bad. and not putting out an ignition signal. It's also possible we just very simply have an open wire or a short to ground or something in the ignition wire. So replacing the distributor is not going to fix that. It wouldn't fix a bad PCM. That's why it's important to understand these systems so that I know for a fact we are getting production of these signals. They are getting to the PCM, and the PCM is working, it's processing them, and sending a signal back to this distributor. Our issue is here. Our issue is with either the ICM's command to the coil, or the coil itself, or however the coil is grounded. We had a coil ground indicated in the diagram. I believe it was just a black wire or something like that, but it's not in this connector here. I believe that that's internal in the distributor. So at this point, what I want to do is I want to access that coil. It'll be easier for me to just pull the distributor at that point. And we are going to see if we can just manually fire that coil. If we cannot, giving the coil a ground and giving it an input, if I do that and this coil doesn't fire, we are done. We are putting a coil in this car, and that is all. Now the only question is, can you do that? Can you put a coil into the distributor, or is the distributor non-serviceable and we have to replace the whole thing anyway? That I don't know, but I don't care because I want to find out exactly what the problem is here so that I can give a better presentation for you guys and show how you would do this on a car where you could maybe isolate the coil. So let's do that. I don't want to just walk into here with reckless abandon and remove this distributor. Got to remember that this has to go in the right place. The cap I'm not worried about. It only fits on one way, and I can just leave the wires connected up there so I don't have to worry about those. Can always look up the information on the firing order and the locations of the wires. They're labeled up already from somebody previously, it looks like, but not worried about that. What I do want to do is take note of the rotor position here, and I want to mark that with some paint or something. This way I can make sure I put my distributor back into the exact alignment that the engine is in, and I won't have to bring the engine to top dead center or anything. So I'm going to make a straight line through all the components there, and when I reinstall the distributor, as long as I don't rotate the engine, we should line up the way we were before, and now I feel comfortable removing this distributor. All right, we are going to test this probably a couple ways here, but what we want to do is first review, because actually for me this is the next day. I think for you this is like 2 seconds later, but I decided to take a break. So let's review where we're at real quick. All right, yes, now I remember. It is very clear to me. We tested all of these components, and we know that all of these inputs work, the PCM works, and the PCM output is good. So our issue can only be a bad ICM, a bad coil, or however the coil is grounded in here, and I'm not quite sure on that. Kind of indicates the ICM has some kind of grounding control as well as some kind of input control. I tried to look up about the ICM. I could not find any description on how it works. But that's okay, because the testing we are going to do is still going to conclusively show if our ICM is bad or the coil is bad. If both of those test good, then, well, then we got a problem. But would have been nice if my scan tool worked. I was thinking, I'll bet there's PIDs for the TDC sensor and the CYP sensor. We could have seen the PIDs with the engine cranking, but unfortunately we have no scan tool communication without the engine running, apparently. So we need to rule out bad ICM or bad coil. I will say replacing this distributor will definitely fix that problem, because no matter what our issue is, we know that it is in this distributor because we tested everything outside of the distributor. We know all of our wiring and inputs to the PCM are good. We know our ignition output is good. This issue is in this distributor right here, and it's just a matter of what is the issue, ICM or coil, and if we can actually replace just one of those if we find that to be bad. So let's go ahead and do some testing on here. All right, so as you can see, I've got a battery here. We are going to try to output a spark here as one of our tests. We've got a bunch of, oh, I see how we have this laid out now. This all makes sense now. So we have right here what is clearly the crankshaft position sensor, is what they are calling it, because we got this reluctor wheel. Ooh, this distributor spins terrible. Wow, it's super loose and raggedy. Boy, honestly, this distributor needs to be replaced anyway, but I'm not just going to call an easy out on this and go, well, the distributor needs to be replaced anyway. No, we're still going to figure out exactly what the issue was, because remember, this car also has a compression problem. So if I can get by just replacing the coil, that is what we are going to do. So let's see here. As you can see, we've got a reluctor here. We've got our inductive sensor, so that is going to be the crank sensor. Right here, we've got a whole bunch of wire plugins. That is going to be the ICM right there. And this obviously is the ignition coil. And look at that, they even give you a positive and negative as well. Check it out. On the positive, I can see a black wire with a yellow stripe. That is this wire up here on the connector that I initially measured power at. So one test we could do, we could take our voltmeter. We could make sure there's power really getting to this coil. We knew it was getting to the distributor, but I can set to continuity scale here. I like to put a little noise meter on there, so if I get continuity, I can hear it. Black wire with yellow stripe to the positive goes right there. Our other end that I tested earlier to the distributor, where we know we got power, is here, and we see we have continuity. So we know we are getting power to that coil, so that is not our issue. Also, we got a green striped white wire and a green striped white wire here. So that is going to be our input on this side. This looks like a ground control or something over here, but whatever the case is, this here is our ignition input. So I want to take that wire out, or at least lift it up enough that I can measure continuity there with our ignition input that we know is reaching the distributor. All right, we are going to test that the same way. We've got one wire up here. That's our white with green. That was our ignition input. We know there is ignition input from the PCM into there. The question is it getting to the ICM? And it is. It does get to the ICM. We know that. We have continuity there. One thing that is occurring to me, how to test this ICM. We would actually probably need it on the car to test the ICM, but it doesn't matter. It actually doesn't matter. If we find this coil is good, this ICM is bad. Period. End of story. So it doesn't matter. We don't really need to test the ICM. We can just test the coil. So the couple ways of testing the coil, one thing is that, again, with the coil test, we should have continuity on the primary windings here. So if we test here and here, we see we do have continuity. It should be probably about an ohm or so, and very, very low resistance on that primary winding. We also, I believe, I may be wrong about this, so this may not be a valid test. I think we should have continuity to the secondary here, and that's going to be really, really high resistance, so we need to crank our meter up. And yeah, we do have very high resistance there, probably like 17,000 ohms or so. There is a spec you can look up. Honestly, I'd never bother with that. I don't like doing resistance tests to validate a part. I only like it under load when it's performing. So I am only going to believe a spark test on this. So at this point, we've got every indication that there's no wiring problem with this distributor that we suspect so far. What we want to do is fire this coil. So before I do that, I want to set up a positive control. I use a coil that I have somewhere around here. Let me find it. All right, well, this will actually work. I have two of them. I've got this little 2-wire coil, and then I have a 3-wire coil. I know they are good, and I use them just as controls to make sure my testing works. So we're going to set this guy aside for a second here, and what I want to do is wire this guy up to the battery. All right, I want to be very careful that these don't cross, because when I connect this to the battery, if this is shorted, that's going to be a pretty miserable experience. So that's why one of these I have insulated, the clip is. All right, this insulated clip is up to battery positive. This is going to be my on-off switch, so I'm going to set him, whoops, there goes my battery positive. Get back on there. All right, so I got my battery positive. I've got the negative, but I'm just keeping that away from the terminal for now. That's going to be my on-off switch. By grounding it out, that's going to be my way of energizing this coil and causing the spark. And then what I've got here is, the last time I tried to do something like this, because you're working really close in this area, you get shocked sometimes. So what I'm going to do to prevent that is I'm just going to use this little light here. And as I energize the coil, that light is going to light up. So I'm going to touch this here, and you know what? It's pretty bright in here. So let me turn out the lights, and you will see that this light will light up, indicating that the coil is working. All right, just putting that to the output. And this doesn't usually work hugely well, but you can see it does light like that. So I know this coil is good. It is putting out spark. All right, so what we want to do now is that same exact test on the ignition coil from this Honda. All right, there's my positive. Now I need my negative here. Actually, I can just control that at the coil, I bet. It'll probably be a little bit easier. So I'm going to connect this up to my battery negative right here. And then this I will just touch to activate the coil. So now I just need to get my little test light over here. The test light is to battery negative, obviously grounding. All right, we're going to set my test light into the coil output. Oh, it lights. It actually lights. I don't know if you guys can see that. Let me reconfigure over here. All right, focusing in on the tester right there. And yeah, you can easily see that that's working. Every time I let off of the ground after connecting it, when I let off the ground, that is going to cause the spark to happen. We see it lights. It lights exactly the same as my good coil did. We are done. This is a bad ICM. All right, that is why I love scientific methods so much. When you do it properly, which means that you consider all the possible variables and you just come down to the one single variable that must be responsible for your observation, you know for a fact that that is going to be what it is. So there is absolutely no question. I don't even have to worry about it. I can call this kid up and I can tell him we can put an ICM module in here if possible, or another distributor. I know that the car is going to run. So the only issue is I already did call my folks at O'Reilly, and it is actually a little interesting. You can get just the ICM module. However, it would take them 5 days to special order it in. You can imagine they don't stock a lot of ICM modules. Who diagnoses an ICM module, right? They just throw a distributor in there when they see no spark after replacing plugs and wires, right? And that would fix it most likely. But the ICM module, it would take 5 days to get here, and it's $118. A new distributor is $160, and they have one in the store right now. So obviously, no brainer on that. Just to be sure, I am going to go ahead and call the owner of the car, and I'm going to confirm what he wants to do, so I will be back. All right, so the kid obviously has been without his car for a couple days already with this issue. He cannot wait another 5 days. It is way more expensive for him to try to Uber to work and things like that. So we are going to put a brand new distributor in this car. I'm a little disappointed because I did want to show just the ICM would do it, but we've got to do what's best for a kid who's working his way through school and doing the right thing. Now, doing the right thing also is considering the fact that, remember, we know this car has a compression problem, so I certainly don't want the kid to be investing too much into this car in the future. He's working all day today. I do have another couple cars that I've got to do, and I'll be filming, but I do think I'll have time to look and see what is the deal with that compression thing. So if there is more video left at the end of this, then I'm just going to include it as bonus footage here. Otherwise, maybe I'll just make a separate video, but God, I've got hundreds of videos on compression issues. So I'll try to just fit it as bonus video on this one at the end. So if I don't see you later, thank you for watching. I hope you found this very educational. We will see you next time. But if this thing goes on, we're going to do a compression thing real quick. Oh my God, I forgot. I do have to show at least the car running after I put the distributor in. My God. Okay, at least we're going to do that. So let me go get that distributor. We'll install it and test it real quick. All right, you can see new distributor in the vehicle. And let's crank this thing up. There we go. Oh yeah, it has a bit of a miss. You might be able to hear it, but it's really not that bad. Yeah, if I got time, we will see what's going on with that compression thing, maybe give him an estimate how urgent this is.